Okay, so 125 is all about managing the hardware, right? It's a control program. It's also yung operating system, and of course, it allows the user to be able to make effective use of the hardware resources. So we've discussed how the operating system manages the CPU, right? So we have discussed that CPU scheduling algorithms, processes, right? Providing an environment for program execution, the CPU. Then last time we talked about memory, which is another hardware resource being managed by the operating system, because we said that most computer architectures will require that programs and data should be placed in the main memory before execution can begin. So we have to discuss how we have discussed how the operating system manages the memory for allocating for running processes, and we also discussed virtual memory. So we have topics like logical memory versus physical memory, paging, segmentation, and other stuff related to memory. Now, the main memory is a volatile storage, meaning when you power down your computer, everything in the main memory is gone. So you don't want your system to be in a way flexible. So normally the operating system or the hardware provides an option called secondary storage or mass storage system, such that even though you power down your computer, the data in the program can still be reloaded later. So the operating system also must manage the storage devices. Right? So this will be the topic of chapter 10. Right? This will be, I'm sure some of you might have heard of some of the topics here, because you all have your own computers, you've experienced issues regarding your computers, you've installed operating systems, so most of these are sometimes or somewhat familiar to you already. Right? So we're just going to breeze through some of the topics here. Right? So these are the main objectives. We'll actually something that is unique to this chapter is this one, the disk scheduling algorithms. Right? And of course this one, because some of you might have not used these kinds of storage. Okay, so as a review, probably a review. So we have secondary storage, mass storage, you have magnetic disk, you have these properties, right? So you have essentially this is the structure of a disk, right? So you have the ARM assembly, and if you open a hard disk, your hard disk, you're going to see these platters, right? And these are the descriptions of that, right? So what are the characteristics? How do you describe disk access? So this is a physical device, right? So you need to define what you call the transfer rate. It's the rate at which data flow between the drive and the computer. So you purchase a computer, you purchase a drive, and then the transfer rate is the rate. Right? How do you transfer how much, right? Or the time it takes for the computer to read data from the disk and place it in the memory. Right? Then you also have the positioning time or the random access time, which is the time to move the disk arm to the desired cylinder. Right? So you have here this red write head. Right? So these are the platters. Right? So you have several platters, and then pag tinuhog mo yan, you're going to get a cylinder, right? So ito isang cylinder to, right? Itong buong yan, this is called cylinder C. And then you have the track, so parang sa oval, so isang ganyan, isang track yan. And then sa loob ng track, you have a disk sector. So this is basically how a disk drive is organized, right? So I hope you remember this. So you have the platter, you have the cylinder, you have the track, and the sector. So the largest unit is of course a cylinder. Right? A cylinder is composed of tracks, and each track is composed of several sectors. And the read-write head must be positioned. For example, if you want to read this sector, then this read-write head must be placed above this to be able to read the data. So there is a rotation that will happen. So you have the positioning time. Okay? It's called sometimes seek time, okay? And you have the rotational latency. Okay? So again, the head must be positioned above the sector that you want to read and then perform the read. Okay? And head crash is the result from disk head making contact with the disk surface. So nalaglag niyo yung laptop nyo. Okay? So ang nangyari, so usually merong space yan, merong air gap yan dito para walang contact yung head dun sa platter. Okay? So nalaglag, na-UP ito, tapos tumama dun sa sa disk platter. Tapos may maririnig na yung bumakaskas sa hard disk nyo. Right? So that's what we mean by a head crash. Right? Na-UP ito, tumama dyan, and yun, sira na yung that's a bad scenario. Right? So this can be removable. So you open your laptop, you remove the disk, or you have a desktop, you remove the disk. Right? And the drives are attached to the computer. So I don't know if everyone here has opened yung CPU nyo, tapos napagtanggal kayo ng drive. Okay? So usually merong connector yan. Okay? So doon sa disk nyo, merong dalawang connector. Yung isa para sa power, yung isa para doon sa bus, I/O bus. So during the early days, yung ginagamit namin IDE. Okay? Integrated Drive Electronics, yung kulay puti na mahaba. Okay? Ngayon, nowadays, ang ginagamit na yung SATA. Okay? Yung maliit lang. Okay? So that's called SATA. And then, for yung mga external, you use USB. Okay? Yung mga external disk. Okay? Yung mga flash disk, etc. sa USB. Okay? So there are different buses that are used to connect the drive to the computer. Okay? And we have what you call a host controller. A host controller is the one that is used by the computer for the bus, and yung disk controller is built into the drive or storage array. So, merong host controller na nasa loob ng computer, tapos merong disk controller na nandun sa device mismo. So, nag-uusap yung dalawang controller, yung host controller and the disk controller. Okay? Yeah. So, hard disk, typical properties of the hard disk. So, marami na ngayong mataas na yung capacity ng hard disk. Okay? And usually, habang umiikot yan, meron tinatawag na RPM, rotations per minute. Okay? So, kung gaano kabilis yung pag-ikot niya para mapuntahan yung isang sector. So, yan yan. Okay, for the performance. And you have this, these are just numbers that indicates how long it takes to access data on a hard disk. Okay? So, during the first few meetings of this class, there were a lot of questions about SSDs and hard disks, which is better, which is faster, etc. So, of course, the hard disk has these properties, rotational latency. So, it's quite, there are moving parts, so it's actually, kumbaga, mabago yung performance niya kumpara sa mga SSD. Right? So, as a trivia, this is the first commercial hard disk drive, 1956. Okay? So, 350, these are the 5 million 7-bit characters ang kayang i-store dun sa hard disk na yan. And it is, 50 by 24 inches platter. So, imagine the improvement in terms of storage. Okay? So, you have this solid state disk, SSDs. Okay? Which is also non-volatile, and usually pag may mga laptop kayo, you're going to have SSDs, kaso limited lang yung kanyang size because it's more expensive. Okay? It may have shorter lifespan, okay? And less capacity, faster, okay? And buses can be too slow because it connects to the PCI, okay? PCI interface instead of having its own separate bus like IDE or SATA. Right? So no moving parts and no rotational latency. So these are just the physical characteristics of the disk. Right? Magnetic tape is another storage, but is usually used for backup because kung nakakita na kayo ng VHS tape or ng cassette tape ng mga lolo-lola nyo or tino-tina na yung kulay brown. Okay? So that's how it's done. So parang iniikot pa yun. So it's quite slow. Okay, so it's just basically used for a backup storage for mainframes, for example. Okay, so this is the more interesting part. How does the operating system view the disk? Okay, so when you install your operating system, you bought a new laptop, plug in the installer, the ISO, right? Tell you, format disk. Okay, so it's the first part. So the operating system has to prepare the disk before it can install itself on the disk. Right? So normally, the disk is like just the memory, the main memory. So these drives are addressed as a large one-dimensional arrays of logical blocks. The main memory is addressed, let's say, as a byte. Okay? And if you have logical memory, you can have pages. And each page that's in the main memory will, let's say, page size 4096. Now for the disk, you also have a blocking called logical blocks, which I showed last time. The relationship between a disk block and a page size. Right? So that's what it shows here. So low-level formatting creates logical blocks on the physical media. The one-dimensional array of logical blocks is mapped into the sectors of the disk sequentially. So you need to have some mapping. Right? As you've seen here, this is the physical divisions of the disk. Right? Let's say the sector size is 512 bytes. Right? That's the minimum. Right? But if you have a logical block that is greater than 512 bytes, then there should be a mapping that will allow you that such that the operating system will see the disk as an array of blocks, but eventually when the operating system reads data from the disk or writes it to the disk, it must convert that logical block into the corresponding location on the physical disk. So there should be a mapping for that. Right? So sector 0 is the first sector of the first track on the outermost cylinder. Okay, so that's the first sector. Now, if you recall your exercise on the bootloader, okay, so the bootloader, meron kayong IMG, disk image, floppy.img, and then you have the first sector, sector 0, 512 bytes, right? And then you have the kernel located in other sectors. You have to load that and jump to that. So that's how it's done. So yung unit doon ay 512 per sector. Okay? So the mapping proceeds in the order through the track, then the rest of the tracks in that cylinder, and then to the rest of the cylinders from the outermost to innermost. Okay? So logical to physical address should be easy. So may formula yan actually. Di ba dun sa exercise nyo sa bootloader, kailangan nyo i-specify yung sector number, track number, saka cylinder number, kung naalala nyo yun, para yung exact position ng pagkukuhanan nyo na sector. Right? So, this is easy to do because you have some computations, but of course, it's possible magkaroon ng bad sectors. So, during our time, na kung saan yung floppy disk pa yung ginagamit namin, since palipat-lipat kami ng computer, usually meron kami, lagi namin na-encounter tinatawag na bad sector. So yung bad sector, nababawasan yung space na pwede mong magamit. So usually merong tinatawag na scan disk, okay? Scan disk that will allow you to detect the bad sectors, right, in the disk, right? Okay. So disk attachment. Okay? So at this point, you should now know that sa perspective ng operating system, disk block ang basic logical unit niya. Pero yung disk block na yon, para i-map mo sa physical, kailangan i-convert yung logical disk block na yon into the corresponding cylinder, track number, and sector number. Okay? So, disk attachment. How do you attach the disk? So, of course, I/O ports. Okay? So, you have I/O. So, this is an example of an input-output device. Specifically, it's called a block device kasi yung transfer ng data niya, block I/O device kasi yung pag-transfer ng data niya ay by bulk, hindi by block, hindi per character lang. So usually in I/O, there are two types of devices. You have the character devices and you have block devices. And this is an example of a block device. Right? So you can attach a disk sa host diretso. Okay? So you have the SCSI. Okay, so you have this particular bus, right? So just an example of a bus na kung saan pwede kang mag-attach ng ng disk, right? And then you can also have a fiber channel, so it's another bus, right? That is basically used for storage area networks, right? And then usually, right, pag magpe-perform ka ng I/O, you're going to specify a bus ID, device ID, and a logical unit. Okay? So, kung gusto mong ma-access ng let's say ng block sa disk, okay, you're going to use this example. Now, yung example yung ginawa niyo sa exercise sa bootloader, hindi nyo directly in-access yung I/O ports ng disk, right? Dumaan kayo sa tinatawag na BIOS, di ba? So you use BIOS interrupts to perform the disk read instead of directly communicating with the disk controller, right? By using I/O ports. Yun yung difference nun. So kung gagawa ka ng operating system na medyo advanced, kailangan mong directly mag-communicate with the hardware using with the buses using the I/O ports. Okay? So we can also have so normally if you buy a disk storage, isang unit lang yan. But you can actually combine them into a storage array. Okay? So halimbawa, kung mayaman kayo sa bahay niyo, meron kayong tinatawag na NAS, Network Attached Storage. Ibig sabihin nun, meron kayong isang box na ganyan, merong limang slots for different capacity of hard disk, tapos that is treated as a single storage. Okay? So sa Linux meron tinatawag na LVM. Okay? So parang ina-access mo yung yun as just one disk, or you can also have RAID, okay? Redundant array of inexpensive disk. Okay? So that's basically the idea. So you can have storage array. So the operating system must also support that. Right? So, yan. So this is an example of a storage area network. Right? Okay, so this is common in large storage environments. Naalala ko, meron dun sa tanong dati, paano ini-store ng mga data center yung sobrang daming data. Right? So usually they have these storage area networks. Right? So you have the clients here, and then they connect to the local area network or the wide area network. You have the server, and the server, ito yung Facebook or kung ano man yung photos.google.com. Okay? So they store that in storage area network, connecting very fast buses, connected to the very fast buses, right? And then, yeah, they are able to serve data, large volume of data, through the storage area network. Okay, may na ba yan? So, yan. So, okay, so SAN is one or more storage arrays, okay? And this is the bus that is being used for those storage area networks. Okay? Yeah. So, wala tayong ganito. Meron akong mini-maintain yung sa project Saray, meron akong mini-maintain na NAS, Network Attached Storage. There's a difference between a network, anong difference ng network attached storage and the storage area network. Okay? There's a distinction between the two. Yung network attached storage or yung NAS, ano yun? Kumbaga, yung communication niya nangyayari using TCP/IP. Okay? So, kumbaga, nakiki-join in siya doon sa TCP/IP network, typical TCP/IP network. Okay? Yung storage area network is a separate entity. So, kumbaga, yung communication niya is using fiber channel, mas mabilis. Compared dito LAN 1 ang ginagamit ay TCP/IP, dito ang ginagamit ay fiber channel. Okay? So I want you to remember that distinction, no? Pag network attached storage, TCP/IP. Okay? Pag SAN, fiber channel or some other high-speed bus communications. Yung connection nila. Okay? Ito pala, sinasabi ko. Okay, so NAS. Okay? Okay, so yeah, meron akong ilang tera, 5 tera yata yun, or 10 na yun nga, isang box na ganyan from Synology. Okay. Then merong may 5 slots ng disk. Okay. Then they are treated as one. So doon ako nagba-backup ng mga data sa project Sarai.ph. Okay. Doon naka-store yung logs, yung uploads, etc. Okay. So, yan. Okay, so this is NAS. So, yan. TCP/IP network. Okay. So, disk scheduling. Okay, so meron kang disk. Meron siyang platters. Okay. And you have an operating system running several programs, multi-programming, Firefox, Events, Terminal, and they all access the disk. Okay. So, how does the operating system make sure that the disk is used efficiently? Remember na only one process will be able to use the disk at a time. Right? Kasi isa lang yung ano niya eh. If you look at the diagram, right, tatlo yung read-write head niya, so mag-move yan. Yung isang process, sabi niya, halimbawa si Firefox, give me sector, this sector. Okay? So, ang mangyayari, kailangan itong mga to, iikot yan para mag-rotate to, para ma-position yung sector na to dito sa kababasahin. Okay? So, there should be a mechanism to make the disk scheduling efficient. Okay? So, the objective is minimizing seek time. Yung, kumbaga, hindi mo na kailangan, minimize yung pag-ikot. Okay? Para makuha mo agad yung data. And also, yung bandwidth. Okay? You also want to achieve high bandwidth. Okay? This is the amount of bytes transferred divided by the total time between the first request for service and the completion of the last transfer. So remember, pag nag-copy kayo ng malaking file, makikita nyo yun, ilan yung sa USB, di ba? Meron yan Mbps per second. Okay? So yun yung transfer rate doon, and the total doon, that will be the bandwidth. Okay? So yun. So, there are many sources of disk I/O requests. I'll show this later. Okay? And this can be from the OS itself, pag nag-load siya ng program, system processes, user processes, etc. So, the I/O request includes the input or output mode. Magre-read ba siya o magre-write ba siya? Okay? And the disk address, saan mo siya lalagay? Okay? The memory, or the disk address, the location pala, sector, and then the memory address kung saan siya ilalagay, and then the number of sectors to transfer. So, na-experience ito first hand nung gumawa kayo ng bootloader. Right? And the OS maintains a queue of requests per disk or device. Right? So, if the disk is idle, then walang ginagawa yung disk. Pag may nag-request sa kanya, okay, handle nyo na agad yun. Otherwise, it has to queue the request, and then there must be a way para ma-optimize yung pag-process ng queue na yun. Okay, you get the idea? So, also note that drive controllers have small buffers and can manage a queue of I/O requests of varying depth. So, pwedeng malaki yung mahabang-mahaba yung queue, pero yung buffer konti lang. So, kailangan mag-adjust. Okay? So, several algorithms exist to schedule the servicing of this I/O request. Okay? The analysis is true for one or more many platters. So, remember, the way the operating system views that disk storage is as a logical array of blocks. Okay? Hindi na siya yung disk, sector, cylinder. Blocks na yung tinitingnan niya, bahala na yung underlying driver nun kung paano niya minamap yung block into yung file system implementation, kung paano niya minamap yung logical block into the corresponding cylinder, track, and sector. Okay? So, we will we illustrate scheduling algorithms with a request queue, okay, 0 to 199, and this is the disk blocks that the process will be processed, and the head is pointed at block 53. Okay. So before we proceed to this, So, so we have the command sa Linux, you have sudo fdisk -l to show the disk being used here. So as you can see, the properties of the disk, you have 465 gig disk, okay, and this is the total in bytes, and this is the number of sectors for this particular disk, okay. So the unit is sectors of 1 times 512, so each sector has 512 bytes, right? So the sector size, logical over physical, okay, so 512, okay? And you have the I/O, the disk label, etc. Okay? And then ito naman, so this is the disk na naka-attach doon, yung nakasama sa unit. Ito yung sinaksa ko yung aking flash drive. Okay? So yung flash drive ko, this is a different device. So 8 gig lang yung drive ko, yung flash drive ko. Okay? 512 din yung bytes niya. Okay? And DOS yung disk label niya. Okay? And this one here is a partition. Okay? A partition on this device. Okay? Bakit pinartition ko siya? Para NTFS siya. Itong device din na to, meron din siyang tinatawag na, yung main device, meron din siyang tatlong partition. So you have the main partition, yung Linux, and you have the swap partition na ginagamit nga for virtual memory. Okay? So this is just the basic idea. So the operating system will try to, may mga processes na nagra-run, okay? They will try to request this access. Nag-LS ako, okay? Kailangan niyang basahin yung directory structure doon sa disk. Pwedeng naka-cache na rin yan sa main memory, okay? Para hindi na magre-read sa disk. Okay? So, merong queue para i-handle yung anong request. Okay, so going back to scheduling, okay? So the first algorithm is called first come first serve, okay? Yung parang FIFO algorithm. So if you use this scheduling algorithm, so nasa 53 ngayon yung head. Okay? So the head will move to next is 98, okay? So, iikot siya para pumunta dun sa, mag-rotate yung platter, papunta dito. So, 100 sa 98, then pupunta sa 183, tapos pupunta sa 37. You get the idea? Kung ano yung dumating na request sa queue, yun yung pag-process niya, ng block na kailangan ng process. Okay? That's FCFS. The next one is shortest seek time first. Okay? So, of course, you have to minimize the seek time. So, in a way, you go to the nearest na block na gusto niyang basahin, na kailangan niyang basahin. So, okay? So, SSTF, scheduling, is a form of SJF. And, pwede siya mag-cause ng starvation kasi laging merong pumapasok doon sa queue eh. So, ang mangyayari kung SSTF yung ginamit mo, pwede yung mga bagong dating na malayo doon sa current na position ng head ay hindi mapuntahan agad, di ba? Kasi SSTF nga yung scheduling. So, it will cause starvation. So, ang mangyayari, so, nag-start sa 53, hahanapin nyo yan. Ano yung pinakamalapit sa 53? Pinakamalapit sa 53 ay 65. So, yun yung pupuntahan niya. Okay? I/O done, trigger the interrupt, okay? Kukunin na yun ng process. Okay? Then, ano yung pinakamalapit sa 65? 67. Okay? So, yun yung pupuntahan niya. You get the idea? So that is shortest seek time first. So somehow may minimize ngayon yung yung rotation, yung seek time. Okay? Yun. The other one is scan. Okay? Yung scan naman, the disk arm starts at one end of the disk and moves toward the other end servicing request until it gets to the other end of the disk, okay? And then babalik ulit. So kumbaga, isang pasada, kung ano yung mahagip niya, service niya. Okay? So, it's called an elevator algorithm. Okay? So, it will require, dito sa example na to 208 cylinders, ito 236 yung movement. Okay? So, this is what happened in scan. So, mula dito, pupunta siya sa pinakaunang block. Okay? Kung ano yung mahagip niya dyan, service niya yung request. Okay. Then, mula dito, babalik naman siya. Lahat ng mahagip niya, service na yung request. Okay, you get the idea? So, this is the scan algorithm. Yung C-scan provides a more uniform wait time than scan. Okay? The head moves from one end of the disk to the other, servicing requests as it goes. When it reaches the end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. Okay? So, simula dito, okay, papunta siya sa taas, service niya, service. Pero pagdating sa dulo, babalik siya, madadaanan niya itong 37. Pero hindi niya muna i-address yan. Babalik siya sa unahan and then sa kanya papasadahan. So this is C-scan. Okay? So yun. Then yung C-look naman, is a version of scan na kung saan ang ginagawa niya, hindi na siya pupunta sa pinakadulo. Okay? Ano yung pinakamababa na block, smallest block, and then the highest block? Hindi na nasagarin. Okay? Okay, tapos na tayo dito, balik na agad. Okay? Idea? So that's what we mean by that C loop. So how do you select a scheduling algorithm? Okay? So, syempre, yung shortest seek time first is the most appealing. Okay? Kasi yun nga, minimize. Scan and C-scan perform better for systems that place a heavy load on the disk, okay? Like yung mga databases. Okay? It has less starvation. The performance will depend on the number and the type of request. So, pwedeng read ba? Pure read lang ba? Pure write lang ba? Okay? So, yun, mga ganong idea. Request for the service can be influenced by file allocation method and metadata layout. So, dito ngayon yung pagpasok ng chapter 11, which we will not be able to cover, yung file system. So, affected din yung algorithm session kung ano yung type ng file system. Marami ng file system. We have FAT12, FAT32, NTFS, ext3, ext4. Okay? So, maraming klase. Depende sa file system na ginagamit. Nakapit na yung algorithm. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. Okay? So, yun. In the case of Linux, ginawa na akong kodigo dito. Sorry. Ano ba palitin mo yan? So, merong command sa sa Linux, it's called iostat. Okay. Okay. If you can see this, so iostat is malaki masyado, sorry. Okay, so ito yung status ngayon ng disk. Okay? So ito yung device. So you have a loop device. Yung loop device for self-mounting lang yan. This is yung kanina, yung hard disk na kanang dito. And then you have ito yung flash disk na ginagamit ko. And you will see here the different properties. Ilan na yung write per second, request per second, read, write per second. And then you have the queue size. Okay? The average queue size, okay? Gaano kadami yung naghihintay? Gaano kalaki? Gaano kadami yung naghihintay sa pag-access doon sa disk na yun? So this is basically the queue length. Okay? So, hindi ako sure dyan. Pero tignan natin. Ayaw stop. Okay? So, okay, average size, the average size in sectors of the requests that were issued to the device, okay? And ito yung queue length, okay? The average queue length of the requests that were issued to the device, okay? Average QU size. Ayun yan. So makita nyo yan dito, average QU. So nagbabago yan and real time kasi maraming request na nagti-trigger dyan, okay? Para pumila doon sa disk. Okay, you get the idea? So, sa Linux, Hindi ko tanda yung command, so dinote ko na lang dito. So sa Linux, meron siyang iba't ibang klaseng scheduler. So ito, disk scheduler. So this one here. So tatlong klase ng scheduler yung ginagamit, disk scheduler sa Linux. You have ito yung current na ginagamit niya dito ay yung deadline. There are CFQ and you have NOP. Right? So you can set that. Ito naman yung pag-check ng parameters, yung performance ng disk. So, yan. So, tinitest niya ngayon for benchmarking. Okay? Pag-time ng pag-read and write sa disk. Okay? So, compare natin. So, ito yung, yung built-in na device about my flash drive. So, compare nyo yung performance. Okay? So, alin yung mas mabilis. Okay? So, napansin nyo na, of course, yung hard disk, ito yung flash drive, flash disk. Okay? Makikita mo yung difference in terms of the performance. Okay? So, yun. Disk management, okay, alam nyo na to. So, you format the disk before ka mag-install. And there are two types of formatting. You have the low-level formatting and the high-level formatting. Low-level formatting, ito yung matagal. Di ba? Pag format kayo ng disk, dalawang option yan, quick format saka yung slow format. Yung slow format, yun yung low-level formatting. So may chinecheck yung mga pinapasadahan lahat. Yung quick format, nililayout lang yung file system. Okay? So that's the idea. And usually sa bawat sector, sa disk meron tinatawag na ECC, Error Correcting Code. Okay? Para malaman kung corrupted yung isang disk sector. So halimbawa tulad na sa amin dati, since parang magnetic disk yung namin, yung floppy disk namin dati, minsan inaamag. Okay? So may mga puti-puti na doon sa disk. So ang mangyayari doon, mark as bad sector, pero yung program namin, C program namin, mariread pa rin namin, pero mark na yun as bad sector. Okay, so yun. So, partitioning, okay, so pwede mo hatiin yung disk, and yan, logical formatting, and usually, di ba, blocks yung unit natin, blocks. Pwede mo siyang i-group for faster access into clusters. Okay? Kung inabot nyo yung scan disk nga, okay? So ang mangyayari doon ay check niya yung bad clusters. Okay? So subspace, alam nyo na naman yan kung para saan yan. Okay? To RAID, ano na natin to. But the idea of RAID is storage arrays. Okay? Hindi lang isang disk, kasama-samahin mo, and then may mga mechanism ka para maano yung integrity and reliability, redundancy actually, basically, para may backup ka. Okay? So example, so iba't ibang levels yung RAIDs. So we have these types. Right? So kumbaga dinuduplicate lang naman yan, tapos merong parity disk para i-check yung integrity ng data mo. Okay? So meron tayong example dito. So sa Linux, meron tayong tinatawag na bad blocks. Okay. So bad blocks will search a device for bad blocks. Ito yung equivalent ng scan disk. Okay. So usually kailangan i-unmount mo muna yung file system para makapag-perform ka ng bad blocks. Okay. So DOS 6.22 yung ginagamit namin dati sa lab. Okay. So memory DIR. Meron yata ng CDOS. CHK DSK. Wala auto completion. So ito. So this is the
pang-check kung yung status ng file system sa DOS dati. So, disk space, directories, okay? And meron din, layong ginagamit yung scan disk, okay? So, this scan disk will perform a scan of the disk for bad sectors. So, ayan. Ganun nga yan. So, nakamark dyan, ilan yung clusters, ilan yung use, etc. So, scan disk did not find any problem on drive C, even though this is just a disk image. Okay? So, ayan. Makikita nyo ngayon yung result ng scan. So, it's basically, para napakasimple nung panahon, pero ngayon mahirap. Medyo, wala pa na exit ng DOS note. So, i-off mo talaga yan. Okay? So, I hope you get the idea of file system and my storage. So, yeah, the purpose lang naman yan is to have, kumbaga, permanent or non-volatile storage para maloload later. Okay, so with that, we end our discussion in COMSI 125. Okay? Sulat niyo yung tanong niyo dyan, and then pass the paper, and then exam will be on Thursday. Last hour. Okay. Kung maliman yung kung maliman yung walang klase sa Tuesday, wala pa rin time lang. Okay. So, Thursday na tayo. So, I hope mag-consult kayo para